Hello friends, myself R.D. Mahajan presenting my video on application of partial differentiation, maxima minima. Example number 1, find maxima minima of x cube plus y cube minus 3axy with the condition a greater than 0 means a is positive. And therefore to determine the maxima minima, we apply the procedure. Let the given function is u suppose as x cube plus y cube minus 3axy minus 3axy. Then the necessary condition is we have to equate dou u by dou x equal to 0 and dou u by dou y equal to 0. Obtaining these two partial derivatives and then equating it to 0. Therefore, differentiating u with respect to x, keeping y constant, derivative of x cube is 3x square, derivative of y cube is 0, and differentiation of this last term is minus 3ay, and then equating it to 0. It implies dividing by 3 we get x square is equal to ay. Then differentiating u with respect to y, keeping x constant, derivative of that term y cube is 3y square. Differentiation of this last term is minus 3ax, derivative of y is 1, and then equating it to 0. From this we get y is equal to x square by a. Substituting that value here in this, therefore we get y square means x square by a, and its square is equal to a into x. We get x to 4 is equal to a square into a, we get a cube x. Transferring to left hand side, we get x to 4 minus a cube x is equal to 0. Taking x common from this, we get x into x cube minus a cube is equal to 0. Nothing but x is equal to 0, and second x cube minus a cube is equal to 0. Finding the factors of this, factors are x minus a multiplied by x square plus ax plus a square is equal to 0. Equating it to 0, we get x is equal to a and x square plus ax plus a square equal to 0. Finding the roots of this by formula, we get imaginary roots. X is equal to minus a plus minus root of b square, a square minus 4 ab, a is 1, b is a square, and divided by 2. Here we have a root of negative term, and therefore roots are imaginary. And we neglect that roots, imaginary roots. Therefore, we put these two values here in this. Y is equal to x square by a. For x is equal to 0, we get that y as 0. The first point is 0, 0. For x is equal to a, we get a square by a, means a. Point is a. Therefore, these are the 2 points at which we have to check whether the function is maximum or minimum. Points are 0, 0. And second point is a. Then we determine the sufficient condition. For that we require to find r. R means dou u by dou x square. Differentiating this with respect to x, again we get that value as 6x, and derivative of this constant term is 0. Then s is equal to dou u by dou x dou y. Differentiating this with respect to y, keeping x constant, derivative 0, derivative of the second term is minus 3a. Then t is equals to dou tu by dou y square. Differentiating this with respect to y, keeping x constant, derivative is 6y. Then we determine the value at that point. Therefore, at first 0, 0, and then at point A, the value of r is here 6 into x, x is 0, therefore it is 0, s is equal to minus 3a, and t is equal to 6 into 0, 0. Then we check the condition, sufficient condition, rt minus s square is equal to r0, t0, 0, minus s square minus 3a whole square, and therefore it is equal to minus 3a square. Square of minus 3a is 9a square. And here the value of rt minus s square is negative, and therefore no maxima, no minima. No max, no minima. At that point, as per the sufficient condition, whenever that rt minus s square is negative, we are not getting any maximum or minimum value. Then we go for the second point. R is equal to 6 into x, x is a, therefore it is 6a. S remains same, minus 3a. And t is equal to 6 into y, y is a, therefore it is 6a. Then once again we find the value of rt minus s square. R 6a, t 6a, therefore that product becomes 36a square minus 3a bracket square, it becomes 9a square, and therefore 36a square minus 9a square value is 27, 9a square, so 27a square. A is positive, the first square of that positive term is positive, value is greater than 0. Then we get either maximum or minimum value. For that we have to check the condition. What is the value of r? R is here 6a. 6a positive value greater than 0, and therefore whenever that rt minus s square greater than 0 along with r greater than 0, therefore that u is minimum. We get that function value as a minimum value. Therefore, we require to find that u minimum. Therefore, point is a. Therefore, put x as a, y as a. We get a cube plus a cube and minus 3axy, a into a into a. It is 2a cube minus 3a cube. U minimum is minus a cube. Therefore, this is the problem of maxima minima. Second example, use Lagrange's method of undetermined multipliers to find the largest product of x, y and z when that are connected by the relation x square plus y square plus z square is equal to 9. And therefore, to determine that largest product, we consider that function as a product of that 3, x into y into z. We call this as equation 1. Second relation is given as x square plus y square plus z square equal to 9. Transferring, we get minus 9 equal to 0, and we call this as function 5 as equation 2. Then differentiating f with respect to x, keeping y and z constant, derivative is yz, constant term outside, differentiation of x is 1. Then differentiating f with respect to y, keeping x constant, y constant, keeping x and z constant, we get xz, derivative of y is 1. Differentiating f with respect to z, keeping x and y constant, derivative of z is 1. Therefore, these are the partial derivatives of f with respect to x, y, z. Then we differentiate that phi with respect to x, keeping y and z constant. Differentiation of the x square is 2x, and all other terms are constant term, derivative 0. With respect to y, we get derivative of y square as 2y, and remaining terms are constant term, derivative 0. Then differentiating phi with respect to z, keeping x and y constant, we get derivatives 2z. Then the first one is dou f by dou x plus lambda into dou phi by dou x equal to 0. That is, substituting the true values. Dou f by dou x is yz, lambda into dou phi by dou x, it is 2x, equal to 0. We call this equation number 3. Then second equation, dou f by dou y plus lambda into dou phi by dou y equal to 0. That is, dou f by dou y xz plus lambda into dou phi by dou y, that is 2y, equal to 0. Equation number 4. Then third equation, dou f by dou z plus lambda into dou phi by dou z equals to 0. That is, dou f by dou z xy plus lambda into dou phi by dou z, it is 2z, is equal to 0. We get equation number 5th. Then multiplying 3 by x, 4 by y, and 5th by z, and adding all. Multiplying equation 3 by x, 4th by y, and 5th by z, we get x into yz plus lambda into 2x square plus multiplying it by y, we get xyz once again plus lambda into 2y square plus multiplying 5th by z, we get xyz plus lambda into 2z square is equals to 0. This is nothing but xyz plus xyz plus xyz, we get 3 times xyz plus 2 lambda we can take common from remaining. Remaining terms are x square, y square, and z square. Y square plus z square, and that is equals to 0. Substituting the value of x square plus y square plus z square as 9 from the given information, we get 3xyz plus 2 lambda into 9 equal to 0. Dividing by 3, we get, that is, xyz is equal to minus 3 to the 6 lambda. We call this as equation number next 6th one. Then from equation 3, we get yz is equal to minus 2x lambda. Put it in 6. We get, therefore, yz means remaining term is x into yz. Yz is minus 2x lambda is equal to minus 6 lambda. dividing by minus 2 lambda, we get x into x as x square is equal to 3, and therefore x as plus minus root 3. Square root of 3 is plus minus root 3. Then put xz is equals to minus 2 lambda y in sixth equation. We get, therefore xz means the remaining is y into that xz is minus 2 lambda y and is equals to minus 6 lambda dividing by minus 2 lambda, we get y square is equal to 3, that is y is equal to plus minus root 3. Then from fifth we get xy is equal to minus 2z lambda. Put it in sixth, we get xy, therefore remaining term is z, multiplied by xy. Xy is minus 2z lambda and that is equals to minus 6 lambda. Dividing by minus 2 lambda, we get z square is equal to 3, and therefore z is equals to root of this plus minus root 3. And therefore we consider with the values with positive sign, neglecting the negative terms, and therefore the solution is x is equal to root 3, y is equal to root 3, and z is equal to root 3. And therefore that largest product is a product of these 3. Therefore it is root 3 into root 3 into root 3. That product is 3 into root 3. Therefore the value of the largest product is 3 into root 3. And for what values we get that value? X is equal to root 3, y is equal to root 3, and z is equal to square root of 3. In my next video, I will discuss some points from that fourth chapter, reduction formula and curve tracing. If you like my video, please share it, as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thanks for